So this is a short demo on introduction to SRE. So I'll be working on a hands-on demo after these classes, but for now, this will be a demo class regarding the SRE and what are its core principles, the history of SRE, what are the objectives, key objectives of SRE, and how it works, and all those things we'll cover in this lecture. So, what will be the agenda of our today's lecture? So, we'll define SRE, what is SRE, and the principle of SRE. What is the role of an SRE in an organization? SRE versus DevOps, what's the difference between these? And then before and after case studies of the SREs. So, let's get started. So, what is SRE? So, SRE, I mean, as you can define, SRE is a engineering approach to IT operations that applies software engineering principles to enhance reliability, scalability, and performance. So basically, the main purpose of an SRE, a site reliability engineer, is to create a scalable, reliable, and a highly available system. So SRE focuses on reducing the manual work through automation using Python, Bash scripts, and then defining some objectives, service level objectives, and managing incidents. So, I mean, that is what I can describe as an wholly as an SRE. So, basically, it was a concept introduced by Google in early 2000s, and after that, it gained a lot of popularity. So, a little bit small history about SRE. So, in between 2003 to 2004, a Google engineer stated the term SRE when he was tasked with making Google's production systems more reliable. So he built a team of software engineers responsible for keeping Google services highly available and scalable. So that was the starting of SRE. The key innovation was applying software engineering practices to operations and leading to automations and reliability metrics and then error budgets. So, I mean, that was the main goal behind SRE. And after that, beyond that point, uh, other big companies also started working on SRE principles, adopting those SRE principles. For example, Netflix, Facebook, Amazon, and Microsoft, all of these companies started adopting those SRE principles. And then it became a industry standard. So for now, all the big companies are using SRE engineers. And so today, I mean, there are multiple tools in SRE that you can work on, like Kubernetes, Prometheus, Terraforms, and there are some AI-based observability platform tools as well. So which made our task easier to monitor and to gain the metrics of the entire infrastructure. So today I discuss somewhat of those things as well in here. So yeah. So basically, what are the key components of SRE? The number one is automation. So number two is monitoring. Number three is SLOs, and then number four is blameless postmortem. So automation that we can do through multiple things like we have automating tools, languages, Python, Bash scripts through which we can do these kinds of things. For monitoring, I mean, we have multiple monitoring tools. For example, Prometheus, Datadog, Grafana. These are all the monitoring tools that we will look after on. And the basic examples of automation would be like, for example, we have created a small Python script to check for system reliability metrics using the Linux commands to check for all the VM logs and all those things. These are some kinds of examples that we can automate through Python and Bash. For example, if one of our VM goes down, we have written a script that would restart that VM automatically. So these are the kinds of automation examples we can work through. So what are the core principles of SRE? So basically, SRE was built on several core principles. I mean, to ensure scalability, reliability, and efficiency in the production systems. So, so basically, what are these What are these principles that we have worked on? So uh, first of all, we had service level objectives and error budgets. So service level objectives are basically a type of agreement contractual agreement between the customers and the SREs. So, for example, if we breach any of these, we'll get a penalty for that. So that is kind of a level agreement for an SRE. And inside those agreements, we have objectives, service level objectives, and service level indicators. So which measures the metrics and what are the metrics for which we have to look up in that agreement. So all these things are defined in an SLI, in a service level agreement. And what is error budget? I think error budget, as you can know, error budget is an acceptable downtime within the given SLO. For example, if your error budget is 0.1% for a month, then it would be 99.9% uptime throughout the month. So you will have, for example, you will only have 43 minutes of downtime in an entire month. So that will be your entire error budget for a month. And then other thing would be incident management and blameless postmortems. So incident management, like it is a structured approach for handling failures and then monitoring, alerting, and escalations of those incidents. So we have multiple tools for incident management like ServiceNow and PagerDuty. All these tools we have worked through, and then these tools we use for the management of incidents and then escalations of those incidents if somewhat goes highest in the production system. And also, I mean, as an SRE, it is our main focus is for the root cause analysis of the incidents of the problems that we have in our production system, and without blaming other entities or other people. So it should be a blameless postmortem. That will be very helpful for our entire system. That will improve our systems. And about monitoring, so as an SRE, it is our duty of, and it is our main focus should be on tracking those system health metrics like latency, CPU usage, traffic, log utilization, all those kinds of things that would affect our system. So that would be a great thing. So we had to focus on those things as well. And then for observability tools, like we have to see logs. We have to understand the system's behavior using traces, using metrics. And then for these, we have tools, as I have told you before, Grafana, Prometheus, and all those tools, I mean, we can use to understand the system's behavior and all those things. And regarding automation, so I mean, for automation, we have multiple tools. As you know, we have IAC tools. IAC stands for infrastructure as a code. So IAC is like, for example, Terraform, Ansible, CloudFormation. These are the tools we use as an SRE because these tools helps us to configure multiple providers. For example, Terraform, as you can say, is a HashiCorp tool. In Terraform, for if we have to configure AWS EC2 instance. So what we'll have to do, we'll have to go to an AWS Cloud Console, and then there we have to configure an EC2 instance and then live that instance. But through Terraform, like within 2 or 3 lines of codes, we can configure that instance from our local using that state file. So we'll learn about that in the future classes as well. But for now, it's a basic idea about Terraform. What is Terraform and why is it so helpful for us? And also we can create some self-healing systems using automation. For example, auto scaling. If we have a higher load, then we can auto scale our production systems vertically or horizontally based on our requirements. And then capacity planning. So capacity planning that is very important for an SRE perspective and then for an production system perspective because for example let's assume we have a e-commerce site and there's a special festival, I mean, in a week. So without ensuring if that the festival is there, if we work on that entire system, then we'll have some spikes, traffic spikes, because at that festival time, peak time, we can't handle the traffic because we know that we will have multiple traffics for that the time period only. So, I mean, for that point of view, we have to ensure that the infrastructure can handle traffic spikes. And then for that, we have to, I mean, plan it before it happened. It has happened. So that is what capacity planning states for. And scalability, I mean, scalability, vertical scaling and horizontal scaling we can have. So vertical scaling is like, for example, if we have one server and then our load goes up, then we can do two things. Either we can increase the RAM and CPU of that server, that will be vertical scaling, or either we can increase the server number. For example, if we have 1 GB, then we can add another server of 8 GB. Will be horizontal scaling. But if we have one server of 8 GB and then we are increasing its size to 16 GB, then that will be a vertical scalability. So, okay. So what is the role of an SRE in an organization? So SRE, I mean, is all about making systems reliable, scalable, and efficient by applying those principles that we have learned before. So by focusing on monitoring, incident management, scalability, the team ensures that the services remains highly available and resilient. As I'm saying highly available because in our SL service level agreements, we have defined a specific metrics that our uptime would be 99.9%. So we have to focus on that metrics as well. So that is why we are saying every time highly available, because it's a, if we have something in a written agreement, we have to work on that, because otherwise we'll get a penalty for not uh, okay. So how can we ensure, I mean, those roles in an of an SRE in an organization? So first of all, we have to ensure high availability of applications, and then automating repetitive tasks like CI/CDs, pipelines, and deployments. So we can automate those tasks, and then implementing monitoring and observability tools. I mean, we have monitoring tools like Prometheus, Grafana, and observability to Datadog, Jaeger. All these tools we can implement, I mean, to ease our monitoring and observability process, and managing incidents and conducting postmortems. So using ServiceNow, we can manage incidents, and then the blameless postmortem should be there, because we can't blame anyone. That would SRE is a cultural thing, so we can't blame anyone for something that has happened. If something has happened, we have to work on the issue. We have to make sure that this doesn't happen in the future. So we'll kind of create a playbook, writing the solution there and writing the question there, so that if in future something like this happens again, then we'll have a written solution for that problem. Okay. So what are the key responsibilities of an SRE? So as we know, the first and the foremost responsibility of an SRE is ensuring the system reliable and maintaining the performance and focusing on the performance of the system. Uh, for example, if a system, for example, if there is an e-commerce site and that has a uptime SLO of 99.95%, that is, we have written in agreement that the site should be 99.9% up all the time in a month. So that ensures that the downtime should not exceed 21 or 22 minutes per month. So I mean, we can do the maths here. So it will be around 21 minutes per month. So that is the expected downtime we can have. But after that 22 minutes, that will be a penalty for us, because we haven't ensured the downtime yet. So that is one thing. And then other thing should be manage the incidents. So for example, if the downtime goes above 22 minutes, then I mean, it will create an incident in a ServiceNow platform or something like this. So what we have to do is monitor and response to those failures, outages, or performance issues using those ServiceNow platforms, and then conduct blameless postmortems after those incidents has happened to improve future reliability. And other thing, like in automation, what we can do to help this thing is to automate alerting and escalation process. For example, we have written a Python script that would check for system log utilizations, in a Linux server. And then using those scripts, if the logs goes somewhat about 75%, then we can send an email or we can send an alert. I mean, we can integrate those things in a chatbot or something like this, and then we can inform our users that it has gone about to 75%. The log utilization of that entire thing is 75% and above. So they can work on that manually. So that is one thing. And other thing that's my one of the favorite thing as an SRE is to automating manual tasks and those repetitive tasks using scripts. So that is one of the most useful things we can do as an SRE. It gives us a lot of time. For example, if there's a manual task and we have created a small Python script to work on that, then it will save us a lot of time in the future because we don't have to do that manual task again and again. So that is one of the foremost thing that we can do. And also, one of the main thing that SRE does is the capacity planning. So, for example, capacity planning and to plan for an entire month for traffic spikes and for future analysis. So that is one thing because as we learn about, as we learned previously in that e-commerce site, if we doesn't know about that there's a festival coming out there, then we would not be able to scale our systems horizontally or vertically for that kind of traffic load. So that is one thing we can do if we have a better capacity planning for that entire system. And then also, other than that, I mean, I mean, as an SRE, we also have to ensure that on the security and compliances of the entire system as well. For example, we can do vulnerability analysis for those system. For if we have an application, for example, if you have a application that is using SSH to connect to somewhat other servers, so then we can do some analysis, some scans for those applications, whether there's a threat or a vulnerability that we have detected in that system use if you are using SSH because it is a remote connection system. Na? So we can have vulnerabilities in SSH. So that is why I mean we have to work on securities and compliances as well. So that is one of the most important things in SREs to I mean secure our entire production systems. So now SRE versus DevOps. So what is the difference between SRE and DevOps? And what are the difference and different aspects of these things that we can differentiate between those two. So for example, SRE is a specialized role within DevOps that focuses heavily on system reliability and reducing toil through software engineering. So SRE is basically a uh, branch within DevOps. So that is what we can tell SRE that focuses on system reliability, system performance, monitoring, observability, those things. So let us take an example, real world example of DevOps versus SRE. So it will be easier for us to understand. So for example, if we have a large scale video streaming service, like let's take YouTube. If we have YouTube, a large video streaming service, then I mean, we are implementing some of the new features. So just imagine that we are working on a video streaming platform and then millions of users are watching videos at the same time. So first of all, what we'll have to do, we'll have to work on three things. So the video should load quickly and without buffering. That is one thing. And the platform doesn't crash during peak hours. For example, if there's a match between India and Pakistan, so that will be a peak hour, that will be in between peak hours. So we'll know we'll have a lot of you viewers in that peak hour. So we have to mm, plan for that as well. Another thing, I mean, we know that engineers will deploy new features frequently. As the viewers are watching, the engineers are deploying new features frequently. For example, personalized recommendations. What are your recommendations? All those things features. So I mean, we have to focus on these three things. So for how DevOps team handle it? So I mean, what DevOps team can do is they can automate software deployment process. For example, if there's a new feature has been developed, then we'll create a pipeline that can deploy the new feature within that application. One thing is this. And the other thing would be IAC, infrastructure as a code tool. So using Terraform, or something like CloudFormation, AWS CloudFormation, we can manage those servers efficiently. So that is one thing. And so DevOps team would handle this scenario like this. But how an SRE would work on this scenario? The SRE would work on the reliability and the scaling metrics of this entire production application. So, for example, the SRE team will ensure that the video streaming service is available within 99.9% of the time, or whatever the given time that is given by whatever the time that has been agreed upon in that SLA, service level agreement. And the second thing would be monitoring and auto healing. So for monitoring purposes, we'll use Prometheus and Grafana, because if we detect some a slow video load time or something like this, so we can monitor that metrics now, how from which time to which time we are seeing that slow load video time, or whatever is triggering that slow load, that we can monitor. And then we can auto scale if we need. For example, if we had an India and Pakistan match, and we knew that viewers will increase tremendously, so what we can do is we can auto scale those servers. For example, if we have 5 servers for now, we can auto scale it to 10 or 15, so that in that way our application will run smoothly. And then also one more thing, that is error budgeting. Error budgeting is like, for example, if our site, that is a video platform, aims for 99.9% uptime, then they should know that this is the uptime that has been agreed upon, and then they have to work on those downtimes, and then allow those controlled risks of innovation. So they should know that we have this window of downtime only, and then they should work on reducing those downtime windows only. So that is one thing, as an SRE, we can do. So, for example, as you can see the difference here in mindset, SRE works through operations, through software engineering processes, but DevOps as a whole bridges the gaps between a development and an operation team. So what is the main focus of an SRE is on reliability and stability of the entire production system. But for DevOps, it is the DevOps and operation collaboration. For example, the CI/CD pipelines to deploy the feature more fast, more frequently. So those things. And what is the approach as an SRE we can do? As an SRE, we'll do automation, we'll do engineering processes, we'll implement those monitoring tools. And what are the responsibilities? As an SRE, the main responsibilities would be incident response, scaling, auto scaling, monitoring, gathering those metrics, those performance metrics for the entire system. Those are the main responsibilities of an SRE. And then what are the metrics? We have metrics like SLOs, SLIs, and error budgets that we'll talk later. This is just a demo. This is just basics of those things, and we'll cover all those things in the future lectures as well. So, creating a culture of collaboration through SRE. What does that mean? So, SRE is not just about automation and reliability. Like, it just fosters collaboration between the development and operation and business team. So we work as a whole, and then a strong SRE culture ensures that teams work together towards the scalability, efficiency, and reliability without sacrificing innovation. So as a whole, like for example, if we are doing some manual tasks, then we can automate that task that will leave us time for new innovations. So that is why I have specifically mentioned that without sacrificing innovation. So how SRE promotes collaboration? So for example, the one thing would be encourage shared ownership between developers and operations. So what is shared ownership? Traditionally, developers wrote code, and then operation teams maintained the uptime for that system or that application. But now SRE removes these silos by making developers and SRE teams equally responsible for system reliability. So that is how they have encouraged a shared ownership between developers and operations. Now, the other thing would be implement blameless postmortems to analyze failures. So instead of pointing fingers when the outage happens, for example, if we have a production application and there's a major outage here, then instead of pointing fingers about the outage, we as an SRE promotes a blameless culture. So postmortems as a whole focuses on learning rather than punishment. And then teams collaborate within each other to document those issues, those fixes, and then the prevention of those outages or those recurrence if possible. Then the other thing would be setting a clear service level objectives in our SLAs, service level agreements, and prioritizing automation to reduce operational toll. So, like the prioritize automation, for example, uh, SRE culture focuses on reducing manual work. And how can we remove those manual works through automation only? And this allows the development team and the operations team to spend more time on innovation rather than firefighting, rather than working manually on those works. So that is one thing. And then one additional thing I would like to add is reliability as a business priority. So as an SRE, we ensure that business teams understand the impact of a system reliability. So teams work together to define SLOs that align with customers' expectation, and then we act as a bridge between in the engineering team and the business goals. So that is one thing. So a strong SRE culture improves team collaboration and then reduces the operational pain and ensures long-term system reliability and sustainability. So that is one thing. And so, yeah, so now, I mean, we'll have some case studies. I mean, I have 2 or 3 case studies before SRE and after SRE. So, for example, in incident response, that is one of the most important thing if you work as an SRE, you have to manage incidents proactively. That is one of the most important thing in SRE. So before SRE and after CRE, what was the difference that has happened in the incident response that we'll talk about? So before SRE, like traditional incident management methods, what was that like no manual response to incidents. So we have to manually respond to incidents, no centralized monitoring leading to delayed alerts, and then frequent outages with no root cause analysis. So these were the things before SRE. And then, like for example, if we had a high traffic e-commerce website that we have talked previously, and that crashes during a festival sale or something like this, then what should be done in this case? The operation teams manually restarts those servers because the website has crashed. So we'll manually restart those servers, and then before SRE, we won't investigate the root cause because I mean, as a whole, I mean, the problem has been resolved after restarting the servers. So that's why we won't investigate the root cause and we won't do any post-mortem or automation for restarting those servers. That was before the SRE scenario. But after the SRE, I mean, we have automated alerting response system. We have centralized observability with Prometheus, and then blameless postmortems and continuous improvements. Now, in that scenario, in that same e-commerce website, that is now, and if that site crashes during a flash sale, now what will happen? We'll write an automation script that would restart the server if the server crash or if the site crashes. Then we'll write an automation using Python or Linux or something like this to restart the servers. Then we'll investigate the root cause of that entire thing. What has happened? What was the root cause? And like doing a blameless postmortem. And then we'll create a playbook like this, and then team writes the entire things to prevent it from happening again in future. And other thing what we can do in this scenario is we can use auto scaling in place. So for example, in a flash sale, if we know the traffic is high, can use auto scaling. What would happen if the load increases in that website? Then it will automatically scale the servers horizontally or vertically. So that is one thing we can do, and that was before and after SRE. Now, for the second use case, we have scalability and performance. So before SRE, servers manually scaled. So manually scaled based on guesswork. So for example, in like this in this the same e-commerce site that we were talking about. So previously, I mean, if we have to scale the servers, we have to manually scale those servers. Like we don't have any data or something. For example, in a specific festival sale, what will be the predicted amount of customers have that would participate in that sale. So we don't have any data or something, so we have to manually scale those servers based on guesswork. But after SRE, we had auto scaling in place, and also we'll use the data from previous festival sales to guess to create a trend on how many customers can participate, and based on those predictions, we can use our auto scaling algorithm to auto scale those resources. So that is one thing that has changed before and after SRE. And the second thing would be performance bottlenecks identified too late. So performance bottleneck identified too late means, so before the SRE perspective, if there were any issues, I mean, the main focus of the entire team was on solving those issues rather than, I mean, creating a system, I mean, creating a team that would, I mean, work on those issues and then prevent it from happening again and again. So that was the main focus before and after SRE. And then, for example, for frequent downtimes during traffic spikes. So before SRE, if we had frequent downtimes, but after SRE, we were using monitoring tools like Prometheus, Grafana, Datadog, New Relic, and then we can monitor what was the time frame in which the downtimes were happening, and I mean, what was the main reason behind those downtimes. If the load was happening, if I mean, the traffic spikes were high, the website has seen some high loads, then what we can do is we can auto scale our website so that the traffic it can manage and handle those traffic spikes more conveniently. So that is one thing before and after SRE. So for example, I mean, for example, let's assume that we have a social media app, and then before SRE, uh, in a before SRE scenario, we had a social media app that would experience huge traffic and surges out during major events, for example, in festivals and something like this. And the servers crashes because they aren't designed to auto scale. And then the engineers had to manually add more servers, but it takes times. And then the user experience was slow because the load time was high and there were more frequent outages. But after the SRE principles, what were the changes that has happened? So in that same social media app, now we were using Kubernetes and we were using auto scaling. So that would help us for the traffic load to manage those high traffic surges during those major events. So that is one thing. So during a viral event, we can use AWS auto scaling or auto scaling as a whole to spin up new servers if there were large load or high traffic load. And also users, so that now if we are using auto scaling, the user experience is zero downtime and the app remains fast because we can auto scale multiple servers at once, and then it would decrease the slow load time and outages of the entire production system. So that as a scenario we has worked in SRE. So now, so this is one thing. I mean, these are the tools, basic tools we can use in SRE. So number one is Prometheus. So Prometheus is an open source monitoring and alerting system. So basically, what Prometheus does is, as a whole, Prometheus monitors the entire system. So Prometheus, like it is an open source tool that has been designed to monitor the system's reliability and scalability. So common use cases would be monitoring our servers, monitoring our Kubernetes clusters, monitoring our AWS infrastructures, and using Prometheus also, it is also an alerting system. So, for example, Prometheus has its own PromQL language. So, using this language, we can create and set up automated alerts based on some metric threshold. For example, if we want to set an alert if our system CPU goes above 60%, then we can create an alert using Prometheus and then and set a threshold limit at 60%. So if our CPU usage goes above 60%, that it will send us an email alert or something like this using Prometheus. So that is a very helpful tool. And what is Grafana? So Grafana visualizes the metrics that are given from Prometheus, and it gives us in a dashboard kind of way. So if you guys have seen before, uh, I mean, if you guys have used Splunk before, then you'll know we can create dashboards using our system metrics, using the data that we have been collecting through Prometheus. Using those data only, we can create dashboards that is visualizing more appealing than a simple table. So that is why we use Grafana to visualize, I mean, creating multiple charts, trend lines, and those things. And Splunk is also a log analysis tool and an event monitoring system. Through Splunk, you can analyze those logs of your entire production system and then create reports, dashboards on those data. So that is one thing. And what is Terraform? So I mean, we have been talking about Terraform in the previous slides. So what is Terraform? Terraform is open. It is also an open source infrastructure as a code tool. So when we say infrastructure as a code, so we are creating the entire infrastructure using code only. So that is why we are saying infrastructure as a code. And it is a tool developed by HashiCorp. So it enables the user to, I mean, define and provision and manage those infrastructures uh, uh, provision that we provide using those declarative syntax that is given through Terraform. So like in Terraform, we'll have a state file, and in those state file, we'll write some code to configure or to provide define those servers. So that is one thing. And I mean, in future we'll write the Terraform configuration for some AWS infrastructure and for some those basic things. But for now, I mean, you can only remember that Terraform is a IAC tool, and it is very useful tool, and we can use this tool to provide us manage those infrastructures and then scale those infrastructure as a whole using the Terraform language. Okay, so now before summaries and key takeaways, I'll talk about the job market of SRE and what are the future of SRE. So as companies are scaling through cloud environment, as we know the today's era, so companies are moving more forward through cloud environment, AI driven approach, and the highly available architectures. So SRE, site reliability engineers, are in high demand now across multiple industries. So I mean, as a whole, as I've seen, SRE is one of the fastest growing tech roles in the AI in the IT industry because it prioritizes on system reliability, automation, and security. And as a business, I mean, this is the most important thing we have to work upon so that our application or our system remains reliable. It should be secure and highly available all the time. As we say, highly available, we are mainly focusing on auto scaling, load balancing, monitoring, scalability, all those kinds of things that makes a system highly available. So that is why I mean I can say so the future of SRE is well and good, and then basically I mean it the salaries should be high enough. I mean depending on the experience and location. So that is one thing. So multiple companies like Google, Amazon, JP Morgan, BlackRock, all these companies are hiring SREs for their high availability systems. So that is one thing. And then SRE is now no, I mean, SRE is no longer just an operations roles now. So for now, it is a blend of cloud. As we know, we are working on cloud security and analyzing vulnerabilities in our production system, and then automation. And the most
Uh,
important thing is, so guys don't have any questions, then we can disconnect now. Okay.